All right, hello. Today is going to be on exponents, exponent laws, and sort of the definition of exponents. And let's just get right into it. So 8 squared, what is 8 squared? Well, the 2 on top of it is the exponent, or some people also call it the power, but it's fine. Exponent is just fine. And then 8 would be the base. And that is equal to 8 times 8. Sorry, I made a mistake there. 8. And there are two eights, and that's sort of what an exponent is. The exponent shows how many of the base there are. So 9 to the power of 9 would be 9 times 9 times 9 times 9 times dot 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 until there are 9 nines. And then there's one more example, just in case that gets you confused. There's 7 to the 6th. There are 6 sevens multiplied together. That is sort of what an exponent is, and finding the value would be the value of the exponent. So now let's go on to exponent laws, which are basically not too hard but not too easy either. So x to the first equals x. There's only one x, so x to the first is still x. X to the 0, well, there are 0 x's. People can get this confused a lot, but x to the 0 equals 1. X to the negative 1 would be 1 over x, because it can be confusing, but hopefully you can just accept it like that. X to the m times x to the n. If you put two variables next to each other, it could be the same as multiplying them. X to the m times x to the n equals x to the m plus n. And you've also got x to the m divided by x to the n equals x to the m minus n. Sorry, I made a mistake there. I will fix that later, actually. But 1 over x to the n would be x to the negative n because of the third law. And so x to the m times x to the negative n would be x to the m minus n due to our fourth law. So that's sort of how to just derive the fifth, and yeah. Next would be x to the m to the nth power would be x to the m times n. Because, well, if you got x to the 6th cubed, there would be 3x to the 6th multiplied together. And then due to our fourth exponent law, we have x to the 18th. So hopefully that makes sense. All right, and then we have x to the y. Xy to the nth would be x to the nth times y to the nth, and hopefully that also makes sense. And just as an example, that's a 6. Yep, that's a 6. 6 times 3 cubed would be 6 cubed, or 6 to the third. Well, 6 times 3, which is 18, and then 18 cubed, which is also equal to 6 cubed times 3 cubed. And so, yep, that's just an example. And these are the exponent laws, the laws of exponents, or exponent laws. So all of these laws are reversible, which basically means that the first equals the last, so you can flip them around as well. So for example, we have x to the m. Yeah, I finally fixed it. X to the m minus n. Well, x to the m over x to the n equals x to the m minus n. And that would also be x to the m minus n equals x to the m over x to the n. Some laws are not reversible like that, so that's sort of why I have to state that. And yeah. Let's go on to the final law, which can be a bit confusing, and if you're just wanting to learn about the front part of the laws, then you don't need to know it. But yeah. So this would be fractional exponents. So x to the m divided by x to the n. Well, let's just split it apart one by one. Well, x to the m is just x to the m. There's no really other way to say it. But x to the 1 over n is sort of what the important part here is. And that's the nth root of x, which basically means how many x's can go into... Okay, this, I don't know how to explain it well. What number to the nth power equals x? That's basically how to say it. So 4 to the 1/2 power, that's the square root of 4, which is equal to 2. Let's do one last example. 125 to the 1/3 power equals the cube root of 125, which equals 5, and on and on and on. You can do that with as many numbers as you want. It's completely fine. So yeah, that would be the exponent law. So hopefully you all enjoyed. That's pretty much it, I think, because there's no other exponent laws. The only hard part about exponents is just manipulating them. So yeah, hopefully this helped, and yeah, bye.